In this series, we will cover the steps to create the basic mechanics for a top-down shooter in Unreal Engine using C++. By the end of this section, you'll have a top-down character moving around with the use of enhanced input. For this demonstration, I'll be choosing a blank project with C++, and I'm just going to name it Top-Down Shooter. With the project open, we can hit Ctrl-N to create a new map, and I'm just going to create a basic map for us to test these mechanics out. And I'll use Ctrl-S here to go on and save the map to the project. Now we're ready to create our first C++ class. So go up to the Tools menu and click New C++ class. We're going to select Character for the parent class, then click the Next button. For the name, I'm just going to call it Simple Character, then change the class type to public and put it in the /public/characters folder, and let's create this class. Once created, your Visual Studio will pick up on the changes and prompt you to reload all, so go on and do that. Once reloaded, go back into your Unreal project and ensure that you see the C++ classes folder with your new Simple Character file. With the new C++ file created, you may be seeing issues in your header file as well as the C++ file. To resolve these, you can go to Project and Rescan Solution. Now we can take a quick look at the files that were generated for us. First, we have a constructor and a begin play method that we'll use for setting up the class. The constructor will primarily be used for setting up values within the project and begin play within the game actually playing. The tick method, being called once per frame, will handle anything that we need to do on a per frame basis. And finally, the setup player input component. We'll use this to wire up the input to the character. Then, if we take a look in the simplecharacter.cpp file, we'll see all the same methods we just looked at, but this is where the logic for those methods will actually be implemented. The first thing we're going to do is create two containers to hold our components. The first will be a uSpringArm component that will hold a reference to our SpringArm component. Next will be a uCamera component that will hold a reference to our camera component. Next, we'll add the uProperty macro to these definitions so that we can see and edit them in the Unreal editor. The same uProperty can be used for both components. Next, we'll go into our C++ file and actually instantiate these components. We'll set our SpringArm to a default subject using the createDefaultSubject method provided by Unreal. We'll supply the type of uSpringArm component to the method, and we'll pass in a text macro with the title we want to name this, and I'll just go with SpringArm. Then we're going to do the same thing for our camera component, the only difference being that the type will be uCameraComponent, and the title will simply be camera. Now, if we were to live compile this, we would see that it does not compile in its current state. If we scroll up, we'll see use of undefined type uSpringArm component. And just so you understand what's happening here, if we were to remove this class keyword from our uSpringArm component, we see that it is no longer defined. And if we look in our CPP file, we see it is also no longer defined in there either. Supplying this class definition makes it a partially declared type, and it makes it referenceable in both files. However, at the time of compiling this, if there is not a full definition for reference, the compilation cannot continue and it will fail. Providing the class keyword in the header file is called forward declaring. It provides a lot of advantages, so just look up C++ forward declaring if you would like to know more. So now let's resolve this error. We need the full code for the uSpringArm component for us to be able to compile this code. So let's use this include path and include it in our C++ file. Grab the path, move over to your file, and paste it in at the top. Next, we'll need to do the same thing for the uCamera component. So grab the include path, head back into your C++ file, and paste the include at the top. If we return to Unreal Editor and attempt the live compile again, we'll see that it does succeed. Now we're going to set up the hierarchy for these components. We'll use SpringArm to call setUpAttachment and pass in getRootComponent to attach our SpringArm component to our root component. Then we'll set up the camera's attachment by calling the same method, but instead of passing the root component, we're going to pass the SpringArm component because we need our camera component to be a child of the SpringArm for it to function properly. And back in the editor, we do another live compile, and we can create a new blueprint class of our simple character that we've created. I'll name this BP simple character, and if we open that up, we will see that we have our spring arm component with a child camera attached to it. Perfect. Now we're ready to set up enhanced input for our character. We'll create two input actions. The first input action will be called IA_move, and we'll use this to detect player movement. The other input action will be called IA_shoot, and we'll use this to detect shooting. Now we'll need an input mapping context to hold our input actions and define what will drive them. We'll name this IMC_simple character context. We'll need to update the value type on our move input action from digital bool to axis 2D vector 2D. This will allow us to handle both the up and down and the left and right for the WASD movement. Shoot is already good as a digital bool, so we can leave that alone. Now let's add these input actions to our mapping context. Use the default mappings drop-down to add new mappings with the plus button. The first action we'll add is the move action. Then expand that to see the bindings for this action. Press the keyboard button and then press W on your keyboard to bind W to this action. Now expand that to see the triggers and modifiers. We're going to add one modifier to our W hotkey. Press the Add Element button to add a new modifier, and then select Swizzle Input Axis Values from the drop-down. This will cause any values from our W hotkey to go into the Y value of this input. Now let's add a second binding, and we'll bind this one to S. We'll go into the modifiers, add the same swizzle input that we added before, and we'll add one more modifier for our S. Since this will represent the reverse of our forward direction, we want to negate the value only on the Y axis. Now let's add the binding for our A button. Here we won't need to swizzle the value since it will go directly to the X value by default. We only need to negate the value since it will be the reverse of our left and right directions. We'll add one more binding for our D key, and we actually don't need to do anything for this one as it's already on the X and it doesn't need to be negated. So now we're done with this input, we can collapse our move and add a new mapping, and now we're ready to add shoot. This action will be bound to our left mouse button. And it doesn't need any triggers or modifiers, so we're done here. Now we're ready to wire up our enhanced input to our character to get them moving around. For wiring up the enhanced input to our character, I like to reference the documentation as it has some helpful information for us. Under the Adding Input Listener section, a little bit further down there's C++ code that we can reference to get the job done. As you can see, it mentions the Setup Player Input component, which is a method we already have declared in our character file. This first section of code is what we'll put in our Setup Player Input component to call the functionality we want to happen when the input is used. So let's grab the code in the first method and bring it into our project. We can see pasting this code in as is presents us with a few issues. While the code seems to have some idea that enhanced input component exists, when we try to actually use it, it shows as undefined. So similarly to our spring arm and camera components, we need to include our enhanced input component. And now we can see that we have a proper reference to our enhanced input component bind action. And this shows that we need a input action for the first argument of our bind action call. And our import also gave us an trigger event reference now. The only thing missing now is a reference to our callback function as well as the input action that will trigger it. So let's create those. The first will be a input action pointer, and we'll call it move action. And we'll want to add a uProperty macro to this with edit defaults only, and I'll add a category of input. Our shoot action will be very much the same thing, so we can just copy paste this whole thing and change it from move action to shoot action. Now we can go back into our C++ file, change the aiming input action to move action, and we'll check if move action actually exists prior to calling this method. Now there's only one argument left to satisfy, so let's create our callback function. We'll grab this function signature from the documentation and use that in our header file. I'll create a private label and paste this in. We don't need the class name, so we can remove that piece of it. And let's call it handle move. And we can use the little screwdriver to create the definition for us in our CPP file. With that in place, we can copy the scoped method name and use that for our callback reference. And now we need to add the input mapping context to our character. So if we return to the documentation, the next section is input mapping context, and a little bit further down we'll find the C++ code we need to add this context to our character. We'll start with the step to expose a mapping context as a property in our header file. So we can paste this in above our input actions. I don't want to use the tsoft pointer, so I'm going to remove that and just use the uInput mapping context as a pointer. And we'll forward declare that as well. Then we'll look at the next step, and we'll bring this into our beginPlay method. We have an undefined type of uEnhancedInput local player subsystem, which we'll need to include in our CPP file. Let's head over to the documentation and grab that include path. Then paste it in. With that out of the way, we need to update the input mapping because we're not using the tsoft pointer. So just check if input mapping instead of everything else. And we don't need to load synchronous, we can just reference the input mapping. And we don't have a priority variable, so we can just change this to a 0 for now. Finally, we have this undefined player variable. For this we can use getWorld and point to get first local player from controller. Now, given that an input mapping exists, we will be adding this mapping context to our input system. Then we would be binding the move action, which is a part of that context, to our handleMove method. To confirm everything is working, we can go into our handleMove method and add a UE log. To help us test this out, we need a game mode that we can set our player controller to our simple character. So let's create a new game mode, and I'm going to call it GM_top-down shooter. We can open that up, and then we can go to the default pawn class and change it to our BP simple character. Compile and save and close this. Then go to your world settings for the level, change the game mode override to our GM top-down shooter. And now we can see our default pawn class is our BP simple character. Now let's open up our BP simple character and choose the Open Full Blueprint Editor and go to the Character Mesh. From here, look for the skeletal mesh asset and change it to Tutorial TPP. This will give our character a visual reference to see them in the world. It could use a few adjustments though. First, we need to lower it to align with the capsule, then adjust the rotation so it's facing forward on the x-axis. Compile and save that, and playing the game should reveal your character in the level. So if we live compile our current changes, we actually fail to build. You'll notice it has errors around our uInput action, missing type specifier int assumed. So we're missing an include here. It mentions our header file with line 37. That's our uInput action right here. So if we search this type in the documentation, we can find the uInput action section and the include path that we're missing. So we can paste in that include path and hopefully resolve our issue. Back in the editor, we can do the live compile again and see that it does resolve our issue. Now let's head back into BP simple character, click on the self component at the top and search for input. And you should see the properties for our inputs. So let's set the input mapping context to our context, the move action to our move action, and the shoot action to our shoot action. With those set, go to compile, save, and head back to the level to run the game. With the output log open, using any of the W, A, S, or D keys should spam the log with the handleMove log that we added to our handleMove method. This confirms that our input is set up and working correctly. Additionally, using the showDebug enhanced input command will show us in-depth information about our enhanced inputs. Pressing the various keys will update the green text to show what value is being sent to our callback function. And it looks like everything is working as expected. This is great. Just great. Now that the move action is bound, let's bind this shoot action. We can copy and paste our handleMove method a few times and rename them to represent our shoot actions. We'll have a start shoot, a handle shoot, and a complete shoot. For each of these, we can use the screwdriver to create a definition in our CPP file. With those in place, we can return to our Setup Player Input component. We can reference our working move action binding to create our shoot actions. We just need to change the move action to the shoot action, update the handle to also be the handle shoot, and duplicate that a couple times so we have our start, our complete, and our triggered. And then update each method to match the trigger. And just to confirm everything's working, we'll add some UE logs to the start, the handle, and the complete. Back in the editor, we can live compile, and then play the game and left click to see if we see our logs in the output log. And we do! We see the start, the handling, and the complete. Looking good. Now we're ready to get this character moving around. So let's head back into the handle move method and fill it out. We'll start by adding an early exit if the camera doesn't exist, because we'll need it to understand how the character will move. Then we need to extract the input data from the f-input action instance, so we can create an f-vector2d to hold that information for us. We can extract the data using instance.getValue.get with a type of f-vector2d. We can do another early return if the incoming movement data is nearly 0, which means there's not really any movement data to work with anyway. Now we're ready to use our camera to understand how to move our character. We can use our camera to get the camera's forward vector, and we can store that in an f-vector variable for later use. Then we can copy this and do the same thing for the camera's right vector. There's a method that we have access to called addMovementInput. The parameters we're concerned with are the world direction and the scale value. Let's start by passing the forward vector and a scale value of 1, just so we can understand what this does to our character. So return to the editor and live compile our changes, and then start the game. Pressing any of the WAS and D keys will demonstrate what our current add movement input is doing, and we can see it's moving our character forward. Since we know that this as it is moves our character forward, and we want our W hotkey, which is bound to the Y axis, to move us forward, let's see what happens when we change this to movementData.Y. And back in the editor, we'll live compile the code and try it again. So we can see that W is now moving us forward, and since we're using the movement.Y, S is moving us backward. Isn't that swell? Now it's time to add the left and right movement using the right vector. And simply enough, we can copy and paste our add movement input here, replace forward with right, and movementData.Y with movementData.X. We'll live compile those changes and start the game again and see how the A and D keys work. And look at that, we have full 360-degree movement. Because we're using the camera's vectors to determine the movement, we can change the camera's orientation around the character and see that the WASD movement still works correctly. So if you wanted a player-controlled camera, this would work great for that. Just great. So now that we've got all that out of the way, let's set this up to be a top-down camera angle for our character. The spring arm component helps us do this with pretty easily adjustable controls for our camera. We can control the rotation of the camera to our character using the rotation of the spring arm, and then we can use the target arm length to determine the distance away from our character. I'm going to go with 1400 for the target arm length and -60 pitch on the rotation. So I'll compile this and head back to play it and see how it looks. So it's looking pretty good, but you may notice that the forward and back movement are now much slower, and that's because we're using the camera's forward vector, which is now pointed at a downward angle. We can resolve this issue by changing the forward vector to not have a Z axis. If we just zero that out and then normalize it, it will be as if the vector is facing truly forward again. And for consistency's sake, we might as well do it for the right vector as well. So if we head back and live compile those changes, we can try moving the character again, and we can see that the forward and back movement feel good again. We're able to move in all directions at the same speed. So there you go. You've got a character moving around, and there's so much potential to take it from here. Thanks for watching, and I hope you learned something from this. Like, subscribe, and ring the bell so you don't miss the next episode where we'll be focusing on the aiming mechanic side of things. And don't forget to follow the newsletter in the description for any updates or demos for things I'll be working on. Take care till then.